All right, welcome everybody. Today we're going to talk about lesson number 50, and we're going to continue with the transformations of the graphs of the sine and cosine waves. So far, we have talked about changes in amplitude, which are represented by the letter A. We have talked about changes in period, which are represented by the letter B. And we have talked about changes in orientation, which means there's a negative sign out front, which means the graph is reflected over the x-axis. Just so you know, we're not really ever going to consider cases where the graph is reflected over the y-axis, and that's because of the fact that because the graph goes on forever, has a domain of all real numbers, if you were to reflect over the y-axis, it winds up looking exactly the same, so that's why we really don't ever talk too much about those. So today we're going to focus on the letter D, but first notice that of course I'm always starting these lessons now with a fresh copy of the sine and cosine. Feel free to draw them for yourself if you want to, but I always just want to make sure that we have a point of reference. So of course you have the sine, which one full cycle is 2 pi, goes from 0 all the way up, all the way down, and then back to 0. Cosine, again, has a period of 2 pi. The one full cycle would start up at 1, go all the way down to -1, and then all the way back to the beginning at +1. So you should go ahead and start by writing down the description of what we're going to focus on today. So today's lesson will focus on changes to the graph's midline. We talked briefly about the midline in an earlier lesson. That is the horizontal line that cuts the y values in half. This is going to be represented in the equation by the letter D. In terms of other vocabulary, these are our vertical translations, which basically means that you're shifting the graph up or down. And then just like always, if there are multiple changes that are happening to the y values, you're always going to do the D or this vertical translation last if there are multiple y changes. And we're going to see that in action in just a minute. So again, since you're most likely watching this on your own, feel free to pause, make sure you've got all that important information written down before we go ahead and get into the actual problems. So not only do we want to talk about the new information in terms of what is D going to do, but we also want to make sure that we remember what the other variables do. So let me go ahead and give you some reminders and then, of course, some new information. So right now we have extended our definition. We could now possibly have y equals a times the sine of bx plus d. So now we're adding d into the mix. Just so you're aware, so far to date, all of the D's have technically been 0 because there was nothing there. This could also be a cosine wave. So whether it's a sine or a cosine, the rules will be the same. And actually, the rules are the same no matter what, if it's a cotangent or a secant. But remember, we're not going to deal with those transformations until we're 100% confident in our ability to do the easier sine and cosine. A few other things that I want to point out here. Number one is that sometimes you will have parentheses around the bx. For now, it's not a huge deal whether they are there or not. Once we start talking about the final transformation, which is actually C, in case you're wondering why we skipped that, that's the hardest one, so we're saving it for the end. And in that case, parentheses will be really important. But for now, they might be there or they might not be there. It really doesn't make a difference. And then I want to point out that for D, sometimes the D is in the front. So if it's in the front, you can leave it there if you're comfortable with that, or you can just move it to the back since that's where we're most likely to see it. So to review what we've done so far, I'm going to separate them into the X changes and the Y changes. So far, the only X changes that we have covered are changes in period, and the way that we have talked about those X changes is that you're going to always calculate the period by using the equation 2 pi over b. Remember, of course, that if there is technically nothing in front of the x, there's a 1 there, so there's no need to do 2 pi over 1, since that always winds up being 2 pi. But technically, if you just see a single x, there is a 1 there. So those are the only X changes that we know so far, and those are the only X changes we're going to stick with for today. But now let's go ahead and review our Y changes. So when it comes to our Y changes, right now, we know that the A is a change in amplitude. We also know that if there is a negative sign out front, that is a reflection over the x-axis. So we are now going to add a change in D to our list. And basically what D does is it moves the graph up or down. And we are going to make sure we understand that when we're talking about up or down, while it technically moves the entire graph, we're going to focus on the midline. And again, I talked about that during the first lesson, but we're going to certainly, use that vocabulary a lot today. And the final thing that you want to make sure that you indicate to yourself is that you are going to do the D last, which basically means if there are A changes and if there are negative changes, you would do both of those before you did any of the D changes. So vertical translations are always last. Whether or not you remember, that has always been the rule, but that's especially important for now. So now that we know all of the old changes and our now new change here of D, let's go ahead and actually put that into action. But first, just a little kind of reminder here, some focus on some of the vocab. Again, you can draw these if you want to, or you can kind of just look and listen. So in the top left box here, we're kind of just reminding you of the period. Whoops. Remember, the period is the distance from the beginning to the end, or one full cycle. Remember that the midline is the horizontal line that goes from left to right and cuts the y values in half. And the amplitude is the distance from the midline to the maximum or the midline to the minimum. And remember, technically, the amplitude is always positive. Any negative in your equation indicates a reflection, but the amplitude is always the absolute value of that A. So then just to show you some kind of additional examples. So now we see an example of an equation where there's a D in it. Again, notice in this case, there is a parentheses around that X. Remember, it really doesn't matter whether it's there or not, but I do want you to get used to it just so you're not surprised. Here we have another example of the midline, and now we're understanding that in each of these cases, whatever that D value is, that is going to be the equation of the midline, the Y equals. Then we have just a quick kind of show over here in the bottom left. We have, again, we're calling this a vertical shift. So notice you have your parent function sign in red there. Notice that the midline is 0. All the midlines so far have been 0. Now, because of the fact that there is a 2, and notice that in this case, the 2 is out front. So remember, the D can be out front or it can be out back. What that means in simple terms is it moves the entire red graph up 2 units. What we're going to really focus on is the fact that it moves the midline up 2 units. Instead of being here at 0, now it's at 2. Then to kind of put it all together, take a look at the bottom right. So again, here you have an example, a specific example with numbers. So you have a parentheses around the X, which remember, sometimes you will, sometimes you won't. What we can clearly see now, or what we hope to be able to see, is that the 1, that is always going to represent the midline. So that would be the dotted green line. Then the A out front, that is the amplitude, which is going to be the distance from the midline up and the distance from the midline down. So how do you kind of take the equation and then take all those different pieces and create the graph? Well, of course, that's what we're going to talk about today. So here in the first example, again, I have a fresh copy of the sign just for easy access, easy reference. You could certainly, draw yourself a copy or not required. So we're going to go ahead and start. I'm going to ask you to graph one full cycle of the sine of x plus 4. Remember that when you're being asked to graph, you always have to focus on the 5 key points. So the sine of x plus 4, if you wanted to, you could certainly feel free to put parentheses around this x if you wanted to, but again, not required. Hopefully a couple of things that you realize here. So in terms of the amplitude, since there's nothing out front, the amplitude is just 1. This 4 is the D, which is where the midline is going to be. And then the period, because there's no change, it's just 2 pi over 1, which means that it continues to just have a period of 2 pi. So not necessarily, you don't have to write that, but again, why not show all the steps here while we're kind of just getting started? So once we have that information, we are again going to go ahead and set up our scale, starting with the x's. Because the period is 2 pi, we are still going to be from 0 to 2 pi with pi, pi over 2, and 3 pi over 2. Make that a little more in the middle there. If you're wondering, are we going to have a time where we're not starting at 0? Well, yes, absolutely. And that time will come very soon. But for now, we're always going to be starting at 0. So basically, the fact that this plus 4 is on the outside means that I'm taking this entire parent function and I'm moving everything up 4. So if I think about what kind of scale I'm going to need, if I'm moving everything up 4, then the highest value I'm going to need is at least a 5. So I'm going to count from 1 to 5 and then show a couple of negatives as well. Again, when you graph a new function here under a transformation, you are forcing the fact that the x values are going to remain the same and the y values are now just going to travel, over that same distance given the new transformation. So in order to enact this plus 4, the first thing you're going to do is realize that the midline is now going to be up here at y equals 4. Essentially, instead of the graph starting at 0, 0, that means it now has to start at 0, 4, pi comma 4, and 2 pi comma 4. Then because the amplitude is 1, you're going to go up 1 for the pi over 2, and you're going to go down 1 for the 3 pi over 2. And so those would be values of 4 and 5, respectively. If you were to go ahead and connect them, you would hopefully notice that it looks the exact same as the original sine wave. Obviously, it looks a little bit, shorter, but that's just because of the scale. Remember, it's not really important that they're drawn to scale. So that's one way that you can graph these. You can start with the midline, and then you can apply the amplitude and any reflections. There's another way, and I'll show you that as well. Instead of starting with the midline and then going up and then going down, essentially what it means is if you go to the original function, you're just taking each of the y values and adding 4 to it. So 0, 0 would move to 0, 4. Pi over 2, comma 1 would move to pi over 2, comma 5. And so on and so forth down the line. So again, you can literally take the parent function and just add 4 to each of the y values, or you can start with the midline and then apply the amplitude and the orientation. So it really is up to you. We're going to kind of talk about it both ways, and then you'll pick whichever strategy you like best. So let's go ahead and try another one. This time we're going to go ahead and use the cosine as our point of reference. So here's our cosine wave. I'm going to go ahead and ask you to please graph y equals -3 cosine of x plus 2. So a couple things to note here. The amplitude is 3. There is a reflection over the x-axis. And then in terms of the d, that means that the graph is moving up 2 because of the fact that there is no value other than just a 1 in front of the x. That's how I know the period is going to stay 2 pi. So as I go to set up my scale, again, I'm going to make sure that I'm going from 0 to 2 pi with a pi, pi over 2, and 3 pi over 2 in between. In terms of what's happening to the y values, maybe you know ahead of time, maybe you don't. You can always add more tick marks, of course, as needed. So if you want to think of it in terms of just kind of easy transformations, what you're really doing is all of these changes are changes in y value. You're increasing the amplitude by 3. You're reflecting it over the x-axis, which means changing the sign from positive to negative or from negative to positive. And then you're adding 2. And again, that's because you have to do the vertical translations last. You always do the d last. So let's say I start with the point 0, 1. I'm going to multiply 1 by -3. That will change the amplitude, and that will reflect it over the x-axis. So that 1 becomes a -3. If I then take that -3 and add 2, that means that that point is now going to wind up at -1. Wherever it starts, it also has to end. So I know that that's going to happen at 2 pi as well. Then consider what happens at 0. If you take 0 and multiply it by -3, it stays at 0, and then you have to move it up 2. So 2, -1, and then again, whatever happens at the quarter point also has to happen at the 3/4 point. Then finally, usually the minimum of the cosine wave is -1. If you multiply -1 by -3, that's going to be +3. And then if you add 2, that's going to be 5. So that is where the middle is going to be. I'm going to go ahead and connect it with a nice, smooth cosine curve. Notice that because of the movement up, my x-intercepts are no longer one of the 5 key points, and I want you to know that that's fine. Again, we are focusing on the 5 key points wherever they end up. So if it doesn't wind up being exactly on the x-axis, no worries at all. So again, I showed you this one more as a matter of doing the algebra. Again, I took every y value from the original. I multiplied it by -3. That took care of the amplitude change and the reflection. And then I added 2 to it. If you should prefer to do it the way I did the first one, you would start at the midline. So remember, the midline would be 2. Then for each point, you would have to move 3 units away because of the amplitude, and then also take into account the reflection. So that's why you wind up with an amplitude of 3 in this direction, and it's going down because of the negative. And then you wind up with an amplitude of 3 in this direction as well, again, because of the reflection. So again, you're going to use whichever of these ideas is really best for you. So feel free to do so. Let's do a couple more. So let's go ahead and take a look at number 3. So for number 3, why don't we go ahead and try to graph y equals 4 times the cosine of pi x minus 1. So the amplitude is 4, and it's going down 1. There is a period change. The period change is going to be 2 pi over b, which in this case is pi, which means the period is going to be 2. I know it might seem strange to have no pi in your period, but honestly, that should be your favorite because it makes it much easier to find the 5 key points. So again, we are always starting at 0, at least for the rest of this lesson. And that's because of the fact that there's no left or right movement. So again, you're only starting at 0, at least through this lesson. So the period starting at 0 and ending at 2 means that halfway between would be 1. And then halfway between that would be a half, which would mean that 3 halves would finish your 5 key points. So now let's go ahead again and get a few tick marks going here. And again, you can use graph paper. You can make them big. You can make them small. I don't really care if they're to scale or not. That's really up to you. So the fact that you have set up your 5 key x values, you have taken care of the pi, and now you need to take care of the 4 change in amplitude and the -1. Remember, a couple different ways you're going to do it. This one, or you could do it. I'm going to do this one algebraically. So remember that the cosine normally starts at the point 0, 1. If there's a change in amplitude, you'd multiply 1 times 4, and that would bring you up to 4. Then, because of the fact that there's a -1, which you're going to do last, that would bring you down to 3. So that's why you know for sure that your graph is going to start at the point 0, 3. And again, if you start at 3, you have to also end at 3. Then think about the second point of the cosine. The second point of the cosine usually starts at 0. If you multiply 0 times 4, it stays 0. If you then subtract 1, that's how you know that you're going to have a value here at -1. And again, whatever happens at the quarter point also has to happen at the 3/4 point. And then finally, the middle of the cosine. The middle of the cosine is usually at a value of -1, which if you then multiplied by 4 would move you down to -4. And if you then moved down 1 again, that's how you would wind up at -5. So the highlighted points in between are just kind of to show you the middle step, but your ultimate finished product here is this purple cosine wave. Again, pointing out the fact that of the 5 key points, there is nothing on the x-axis, which again is perfectly fine. All the things you want to confirm here. 1, you want to confirm that the midline is in fact in the middle. So at -1, hopefully you would agree that the distance from -1 to the top is equal to 4, which is the amplitude. And then the distance from the midline down is also equal to 4, which is really exactly how that's supposed to work. So your final product, again, should be there in purple, and lots of different ways that you can get there as long as that winds up being your final product. Again, just to reiterate, through homework 50, every one of these graphs starts at 0. That will change once we get to lesson 51. Let's just do one more. So number 4, let's go ahead and consider y equals 1 minus the sine of 5x. So in this case, the one that's out front, that is the d. Again, you're fine to leave it out front if it doesn't bother you. Personally, I prefer to have it in the back. So I'm going to move it to the back. So from here, again, the amplitude is staying 1 because technically in front of this here is just a 1. So the amplitude is 1. There is a reflection over the x-axis. And then because of the d, I do have to go up 1. There is a change in period. 2 pi over b is going to be 2 pi over 5. So I'm going to need that in terms of setting up my scale here. So I'm going to go ahead and start by labeling my 5 x's. So 0 and then 2 pi over 5. While we're here, I want to give you a couple of hints for finding midpoints. We're going to be finding midpoints a lot in the next couple of lessons. So I just want to give you some tips for finding midpoints. So if you're taking a midpoint, which of course means to divide by 2, that also means taking half. So there's 2 really cases. If you're taking half of, let's say, 4 pi over 3, in this instant, you're taking half of something that is even. If you're taking half of something that is even, you're literally going to take half of the numerator. So half of 4 pi over 3, half of 4 pi is 2 pi, and then still over 3. So if you're being asked to take the midpoint of something with an even numerator, you're going to take half of the numerator and leave the denominator alone. If you're being asked to take half of something like 3 pi over 5, where in this case, you're looking at an odd numerator, the easiest way to do this is to double the bottom. So half of 3 pi over 5 would be 3 pi over double the bottom, 10. So again, you're going to be taking a lot of midpoints in the upcoming lessons. So this is my trick. Again, if you're taking half of 4 or half of 4 pi, that's easy. But if you're taking half of a fraction, if the numerator is even, take half the top. If the numerator is odd, double the bottom. So keeping that in mind, as I go back to fill in my 5 key points, if I'm going to take half of 2 pi over 5, the numerator is even. So half of 2 pi over 5 would be 1 pi over 5. If I now need to take half of pi over 5, since 1 pi is odd, I'm going to double the bottom, which would be pi over 10. And then if I do pi over 5 plus 2 pi over 5, that's 3 pi over 5, which I then have to take half of. If I'm trying to take half of 3 pi over 5, again, I'm going to double the bottom to give me 3 pi over 10. So now that I have my x's, I'm going to go ahead and do my y's. This one I'll do using an alternate method. I'll do the midline method. So again, you can do whichever one you prefer. So if you're using the midline method, that means that you would start at 1. That would mean that the graph has to start on the midline, be in the middle at the midline, and then be at the end at the midline because this is a sine wave. Then because of the fact that the amplitude is just 1, you would go 1 unit away. And then because of the fact that there's a reflection, it just means you would go in the opposite direction. So normally from the midline, the sign goes up 1, but here you're going to go down 1 because of the negative. And then at the 3/4, normally you'd go down 1, but in this case, you're going to go up 1. And here would be your graph. It would exist between 0, 1, and 2 as far as the y values go. And again, your other option would be to take the regular starting y values, multiply them by a negative, and then add 1, and you are free to do whichever one of those you prefer. So the final thing in the lesson is, can you work backwards? Which means if I give you an equation or if I give you the graph, can you write the equation? We did a whole bunch of these during the second part of lesson 49. The difference now is, of course, there's going to be a midline other than 0. So here's my suggestion. You're going to actually start with the D. So in this case, looking at the y values, you have a highest y value of 3 and you have a lowest y value of -1. So hopefully you understand that +1 is between them. This is the midline, which means that's going to be your D. So D is going to definitely be equal to +1. So then you have to decide, is it a sine wave or a cosine wave? And hopefully you would agree that it's a cosine wave. Hopefully you would further agree that it's a negative cosine wave. Then hopefully you would agree that if the midline is D, there's going to have to be a +1 in the back. So now consider the amplitude. The amplitude is the distance from the midline up or from the midline down. And in both of these instances, that's clearly going to be a 2. So you've taken care of the reflection, you've taken care of the amplitude change, you've taken care of the midline change. All that's left is the period change. So notice that in this case, your cosine is starting at 0 and it's ending at 6 pi over 2. You have to be careful because even though it's only labeled to 5 pi over 2, you have to make sure that you know that it's 6 pi over 2. And of course, that would simplify to be 3 pi. If the formula for period is 2 pi over b, and we know that the period has to be 3 pi, I'm going to go ahead and set up my proportion. Cross multiply, so 3 pi times b is equal to 2 pi. Go ahead and cancel the pi's. Divide by 3, and that's how I know that this is going to be y equals -2 times the cosine of 2/3 x plus 1. Remember, feel free to put a parentheses around that 2/3 x if you would like. Let's do one more. Notice here you have multiple cycles of waves, so you have to highlight just one. You're always going to start on the y-axis because up until this point, there is no movement left or right. So if I start on the y-axis and then I go in the positive direction, hopefully you can agree that that is clearly a sine wave and it's clearly a positive sine wave. Then you're going to find the midline. So the midline is here at -2. So I know that that's going to be my D. Then your amplitude is the distance from the midline up or from the midline down. However you slice it, hopefully you would agree that that is 3. Finally, there's a change in period. The formula for period is 2 pi over b. Based on this picture, it is saying that that is equal to 6. So cross multiply, 2 pi equals 6b. So b is equal to 2 pi over 6, which of course would reduce to pi over 3. So your final answer to this equation is 3 times the sine of pi over 3x and then -2. And again, feel free to put a parentheses around that pi over 3x if you would like. So that concludes lesson 50. You're now going to go ahead and try homework 50, which is going to ask you to graph a couple from the equation and then given the graph, find a couple equations. So thanks very much, guys, for tuning in, and we will catch you next time.